Albert Einstein was almost elected president of Israel. Yeah, I know, sounds like clickbait, right? But it really happened. How? Let's jump to April 2nd, 1921. Albert Einstein steps off the SS Rotterdam. Next to him, his wife, Elsa. Spoiler, not his first wife. People are waiting on the New York harbor. Reporters, police, journalists with notebooks in hand. They welcome him like a rock star and hit him with the dumbest question you could possibly ask a physics genius. What do you think about prohibition, professor? Because, yes, in 1921, alcohol was illegal in the US. Weird times, but okay. Einstein just smiles and replies, I don't drink, I have no opinion. But why New York? Why now? Answer is simple. Europe, especially Germany, was falling apart, crushed by war, bankrupt by reparations, drowning in inflation, and like always, they needed someone to blame. Einstein, he was perfect. Why? He was the only member of the Prussian Academy of Sciences who refused to sign a letter supporting Germany's war effort. He was pacifist, but also a Jew. And to the far-right nationalists, that made him enemy number one. Paramilitary groups started showing up at his lectures. People questioned not just his politics, but his science. Rumors spread that he wasn't good at math, that the equations in his papers were actually written by his wife, Mileva, first wife, a woman he never even mentioned in his Nobel Prize publication, even though the money from the Nobel, it went to her. Strange, right? But it didn't stop there. They said he flunked school, failed his first college entrance exam, had an affair with his own cousin, clashed with his professors too, struggled to find a job, and after his death, someone stole his brain. No wonder some people today think his life story sounds like a myth, like a perfectly engineered PR campaign. As if Einstein wasn't a genius, but the greatest fraud in the history of science. What's the truth? Let's find out. I know, it might sound strange, but Einstein wasn't born a genius. Actually, his development was very slow and had huge problems with speaking. So big that the maid in their house used to call him mentally disabled. And no, that's not a joke, especially not from her. I mean, back then, in Germany, at the end of the 19th century, even not so rich middle-class families sometimes hired maids, at least for simple housework. It was more like cheap labor than real luxury. So yeah, that wasn't a sign of a big money or anything. Einstein's parents were really worried. I mean, he could barely speak, or actually he had serious trouble speaking at all. So they took him to a doctor, but still nothing really changed. Little Albert just didn't talk for a long time. And then when he finally started, before saying anything out loud, he would whisper the whole sentence under his breath, like he was doing a rehearsal or anything, or talking to an imaginary friend. Come on, who doesn't do that? What? That's not normal? Still, this doesn't sound like the beginning of a genius, right? But somehow, what looked like a weakness turned out to be his superpower. Einstein didn't think in words. He thought in pictures, in visions, in mental experiments, and that would change the face of physics forever. After all, not everyone back then could imagine a train moving at the speed of light. But okay, no spoilers yet. Einstein's family came from Jewish merchants who had lived in southern Germany for generations. They lived in a city called Ulm. They felt more German than Jewish. At least, that's what they thought. But it was their nationality that stopped Einstein's father, I mean Hermann Einstein, from getting a higher education. So Hermann, Einstein's dad, went into a business instead. And not very successfully, he was a gentleman, and the family was never rich. What about his mother? Paulina was strong, with a sharp tongue and a strong personality. Einstein got more from her than just the nose. His sharp tongue was kind of a problem, actually. It caused him a lot of trouble later in life, but okay. Funny thing, Albert Einstein, they wanted to name him Abraham, a classic Jewish name, but Einstein's parents thought then maybe that sounded too Jewish, so in 1879 he became Albert. That's all. That's the whole story. A quiet and shy boy. That's how people who knew him as a child described the future genius. Albert's parents were not very religious, so at first they sent him to a Catholic school. It was simply the closest one to their house. On almost every website you will find the same story, that Albert Einstein failed math in school, he was bad at math, he wasn't a genius at all. Sounds great, right? Especially if you struggle with math. A little light at the end of the tunnel. Maybe there's still hope for you. It's complete nonsense. Einstein was actually amazing at math, even compared to other smart students. From a young age, he had a very logical mind, loved numbers and studied topics on his own. Things most people first see in college. I mean, he supposedly learned calculus and differential equations by the time he was only 15. His school grades were full of top marks. But then, I mean, we need something. We need a plot twist. In Switzerland, there were different grading systems. In one school, 6 was the best grade. In another, 1. So the grading systems were different. And because of that, someone once read Einstein's old report card the wrong way. They saw all the 1s and thought, yeah, he was a genius, but at math, not so great at math. But it was actually the complete opposite. Even as a teenager, Einstein already had one trait that stayed with him for life. A total lack of respect for authority. I mean, school bored him. He hated strict rules. He had too many of his own ideas and not enough patience. So the results are simple. Constant fights with teachers. And that's putting it lightly. He really went at it with them. After one of these arguments, a professor even told Einstein that he would never amount to anything. In the mid-1890s, Hermann Einstein's company went bankrupt. He worked in city electrification but didn't get the next government contract. So the family moved to Italy and left 16-year-old Albert alone in Munich to finish school. And yeah, he did finish school, but on his own terms. Half a year before graduation, he ran away to his parents. Seriously, he got a doctor's note, quit school and moved to Italy. And most people will tell you it was because there was too much memorizing. And Einstein hated that. Maybe, I don't know. Maybe it was the strict Prussian style system, or that German obsession with order and discipline. That makes sense too. Honestly, I think it was something else. In Germany, when you turned 17 back then, you didn't get a new car for your birthday, you got a ticket to the army. And if someone really didn't fit in there, well, that someone was Albert Einstein. A few years later, already a Swiss citizen, Einstein was actually called in for a military checkup. And what happened? All I know is that the board said unfit for service, probably a grade D. The reason? Flat feet and excessive foot sweating. I know it sounds funny, but Einstein was seriously happy about it. But to be honest, his feet weren't the real problem. Since he was young, Einstein hated violence, hated authority and military discipline. That dislike of the army, of a pressure and of a blind obedience stayed with him forever. That dislike of the army will back in this story in a big, loud way. But let's go back to Italy. After running away to his parents, Einstein did something most of us probably wouldn't do. At least, not by choice. He started preparing for university entrance exams all by himself. No tutors, no courses, no cheat sheets from the internet. Total lone wolf. And that's important because back then, end of the 19th century, in Europe, especially in Switzerland, you didn't need to finish high school in the usual way to get into university. What really mattered were the entrance exams, and if you passed them, you could get in even without an official diploma. So what happened next? Einstein wanted to get into the Polytechnic school in Zurich. Maybe it wasn't the most prestigious university in Europe, but still a solid one. But the problem? He failed. And no, that's not a joke. Einstein didn't get in on his first try. Critics love to point this out. Something like, haha, the genius failed the exam. But if you look closer, you will notice something, that he only failed the humanities, mostly language subjects, math, physics. He did great in those. He did so well in math and science that the exam board recommended he finish high school in Ararau to get a full general education, kind of like a diploma or something like major exam. On his second try, he walked in like he owned the place. Entrance exams, he crushed them. And it was at that university in Zurich where he would meet the people who would change his life. Oh, and I don't just mean his career. I'm talking about his love life. In 1896, Einstein starts university. He's 17 years old, and he doesn't have citizenship in any country. Seriously, he gave up his German citizenship. He was done with the Prussian system. And the Swiss passport? That would take a few more years. So yeah, he studied as a man with no country. For someone who would spend his whole life fighting authority, I think it was a perfect start. At that time, Einstein had one favorite saying: blind obedience to authority is the biggest enemy of truth. And that wasn't just a quote. He lived by it. 120%. Maybe too much. Later he calmed down a bit. But anyway, he started his studies. And he was disappointed. At first, Einstein got excited about the lectures with Professor Weber. He taught physics. He focused mostly on thermodynamics and experimental physics. But over time, total letdown. Weber was the classic by-the-book teacher. He ignored the newest ideas in theoretical physics, especially the work of Maxwell, Boltzmann, and Lorentz. Einstein, on the other hand, was totally into those ideas. Electromagnetic waves, the ether, the speed of light, and he just couldn't understand why Weber wasn't teaching them. Especially why he wasn't teaching Maxwell's equations. This was a real breakthrough, a total game changer. Maxwell combined electricity, magnetism, and light waves into one big theory. Thanks to him, we know that light is an electromagnetic wave, and it always moves at the same speed, no matter who is watching it. 300,000 kilometers per second. Einstein read Maxwell's works when he was still a kid, and something clicked. He started doing what he loved most: thought experiments. He imagined, what if I was flying at the speed of light next to a beam of light? What would I see? Would the light wave freeze? What would that even look like? Now, imagine his frustration when there wasn't a single word about those topics in class. No Maxwell equations, no ether, no electromagnetism. Einstein lived for this stuff. He was done. He even stopped calling Weber Herr Professor. He started saying just Herr Weber. Back then, that was like calling your professor dude. Weber didn't take it lightly. He gave Einstein a low grade, even though he knew the guy understood physics better than anyone else. But in the academic world of that time, disobedience had a price. and it was a big one. Weber was an old-school teacher. He cared more about discipline than innovation, so he took his revenge in the most elegant way he could, with a bad grade. And Einstein didn't just argue with Weber. There was also Hermann Minkowski, and his story is actually pretty interesting. He was ethnically Jewish, spoke German, but his last name sounded very Polish. And yeah, his family really did come from Poland. He is considered a math genius. He taught mathematics at the Zurich Polytechnic. Einstein was officially in his class. Officially, because in reality, he almost never showed up. Minkowski later said Einstein was lazy. In German, he called him ein fauler Hund. But here's where the real irony kicks in. A few years later, it was Minkowski who realized that Einstein had created something way bigger than even Einstein himself thought. From now on, space and time can no longer be seen as separate. They are one and the same. Space-time, said Minkowski in 1907, literally and figuratively. That was next level. Minkowski not only understood what Einstein was talking about, he translated it all into the language of mathematics, and he created what we now call Minkowski's spacetime, a four-dimensional model of reality where time is the fourth dimension, right next to length, width, and height. That was the moment physics got an upgrade to version 2.0, and the best part? Einstein had no idea what he just actually done. Minkowski was the first to see that the theory of relativity wasn't just a random idea about light. It was a whole new geometry of the universe. Honestly, isn't that kind of ironic with Einstein? So far, you've got this young, cocky guy with no passport, who doesn't follow rules, breaks the system, and starts asking questions no one dared to ask before. Where's the wild-haired genius? He is hidden, just like in all of us. Einstein studied theoretical physics, and at the end of the 19th century, that field was still very new. If you gave him a screwdriver and a vacuum cleaner pipe, it would probably end in an explosion. And I'm not even joking. He actually once broke lab equipment so badly he got injured. That's why he quickly realized that real experiments weren't really his thing. His true experiments happened in his head, and that was his superpower. Einstein would sit on a chair, close his eyes, and mentally launch a train moving at the speed of light, and then he would imagine jumping onto the roof of that train. Seriously. In 1900, he finished his studies at the Zurich Polytechnic. Even with all the fights with professors and skipping classes all the time, he still graduated with an average grade of 5.7 out of 6. So, not that lazy after all, I think. But then, real life began, and it hit hard. Albert sent his CV to universities all over Europe. He wanted to become an assistant to a professor. The reactions? Either polite rejections or total silence. In some cases, he wrote twice and still got no answer. But you know what? Maybe the problem wasn't the universities. Maybe the problem was Einstein himself. The guy had no sense of social tact. Instead of a normal motivation letter, he sometimes sent a professor a critic of their scientific work. Like, hello, I would like to work with you. Also, you are wrong about this, and here you make a mistake. Pretty bold, right? Einstein was also convinced that his old professors from the Polytechnic were giving him bad references on purpose, that they still had a grudge against him. And honestly, looking at how he argued with them and how he treated authority, maybe he had a point, but I wouldn't bet my life on it. The truth is, it wasn't easy for him. For over a year, he lived day by day, took small jobs, gets private lessons, barely made ends meet. And then a choice appeared. It looked small at first, but later turned out to be a total game changer. Albert's father, Hermann, was already living in Milan at that time. He had a company there, and he suggested that his son should give up on physics and just become an engineer. A calm job, stable life, regular salary. Einstein actually thought about it seriously. In 1902, with help from a university friend, Hans Albert Bezzo, Einstein got a job at the Swiss Patent Office in Bern. His position, technical expert, third class. Not the most exciting job, but a job. To get promoted, he needed a PhD. Einstein tried several times, but the Polytechnic kept rejecting his applications. And to be fair, he didn't help himself much. Again, no sense of diplomacy. But you know what? He actually loved that job at the patent office. Seriously. After a year of rejection, silence, failure, and barely surviving on tutoring, it felt like luxury. The salary? Higher than what he would have made as a university assistant. Stress? Zero. Professors? Also zero. And the best part? He had time. After work, he would sit down and write. In the evenings, at night, in cafes, instead of fighting with the academic world, he just did his own thing. He wrote about light, about time, about a world that didn't work the way everyone thought it did. And so, 7 years passed, 8 hours a day, 6 days a week at the office. But in the meantime, he was creating things that would shake the world of science. So maybe if you are stuck in an office 5 days a week, don't worry, it's not a life sentence, it's just an excuse. Einstein worked in an office too, and it was there that he came up with the ideas that later won him the Nobel Prize. Seriously. I mean, in 1905, his Annus Mirabilis, or Miracle Year, Einstein wrote a letter to his friend Conrad. He called Conrad a frozen whale and asked, "Why would you disappear, man?" You know, it was classic friend talk. And then, in the same message, he dropped a few of his thoughts, just like that, super casual. And those thoughts, well, 10 years later, gave him a Nobel Prize. Imagine that, your body sends you a random message, and a few years later, he wins a Nobel for it. That's how it went down. So, what was so special about that letter? Well, Einstein wrote, "We really need to meet. I've got 4 small space papers for you." Something like that, or just like that. What was behind that word small? On the first page, Einstein writes about the photoelectric effect. He shows that light doesn't only move like a wave. It also acts like a stream of tiny particles called quanta, what we now call photons. And that was a shock. At that time, the wave theory was king. And here comes Einstein saying, "Hey guys, quantum physics is coming." At first, people weren't really convinced, but Max Planck, the father of quantum mechanics, read Einstein's paper. How he even got it, we will talk about it in a moment, okay? And he saw it, and he said, "It's huge." He saw a new foundation for physics, and it was this paper, not the Theory of Relativity. This paper about photoelectric effect will bring Albert Einstein the Nobel Prize in 1921. According to classical physics, a light wave shouldn't be able to knock electrons out of metal, no matter its frequency. But Einstein showed that it's not about intensity, it's about the energy of a single photon. And he did this before the word photon even existed. He proved that it's not how long you shine the light, but what kind of light you shine. And basically, he invented the photocell. On the second page, Einstein wrote a paper where he tried to figure out the real size of atoms. Actually, he was trying to prove whether atoms even exist. Today that sounds obvious, but in 1905 it really wasn't. Many scientists still saw atoms as just as useful idea, not a proven fact. And Einstein used something called Brownian motion, that weird shaking of tiny particles in a liquid, and showed that you can calculate it. What we see under the microscope only makes sense if atoms are real. This paper gave the first real numerical proof that atoms actually exist. The third paper was pure math about chaos. Einstein looked at how tiny particles move inside a liquid. And then he did something amazing. He connected those observations with the equations of thermal statistics. This laid the foundation for statistical thermodynamics and the physics of complex systems. In short, he showed that even microscopic chaos can be predicted with math. And finally, on the fourth page, a humble one. The Theory of Relativity. The last paper from 1905 was called On the Electrodynamics of Moving Bodies. I know it sounds like something about wires, right? Don't be fooled. This was the moment Einstein destroyed the idea of absolute time and absolute space. He introduced the idea that time and space are relative. They depend on how fast you are moving. And in one of the follow-up notes, he writes a little equation. Energy is mass times the speed of light squared. But it's not just a physics equation. It means mass is frozen energy, and energy has mass. And he did all of this in 1 year. Not as a professor, not as a Nobel Prize winner, not as some academic superstar. He did it as a clerk, a third-class expert without a PhD. The year 1905 went down in history as the Annus Mirabilis, the miracle year. 4 papers, each in a different field. Each one could have won someone a Nobel Prize. Einstein did it in a few months. And he did all of that in his free time. So what did he do with it? He wrote 4 papers and published them in Annalen der Physik, one of the most important German science journals of that era. In 1905, the editor-in-chief was famous Max Planck, the father of quantum physics, the same guy who solved the ultraviolet catastrophe. The problem with what happens if you heat up an object to infinity. But okay, you might ask, Einstein wasn't a professor, he wasn't famous, he didn't even have a PhD, so how did his papers get accepted? Simple, because Planck read them and got interest. That's it. Planck was one of the first to recognize their importance, even though at first he didn't fully understand them. He read the papers on special relativity and had serious doubts. According to some sources, after reading one of Einstein's papers, he said, "It goes against intuition, but no one can prove it wrong." And that's exactly why he published it, because he knew that science isn't about whether something feels right, it's about whether it can be disproven. And Einstein wrote with such logic and clarity that you simply couldn't. Now you are probably thinking, well, the guy published 4 groundbreaking papers, boom, career, fame, professor job. Well, nope, not even close. For next 4 years, Einstein kept working at the same patent office. No awards, no innovations from universities, no prestige at all. What he did have was a lot of work and even more drama. His personal life at that time was, let's say, just as complicated as his equations. In 1905, Einstein was only 26 years old, and he was already married, a father of 2 children, and deeply involved in a relationship that still sparks debates even today. His wife was Mileva Maric, a Serbian woman, a physicist, a mathematician, and as more and more people suggest, his co-author. Mileva wasn't just a tea-serving wife. She sat in the same lectures as Einstein, in the same classrooms. She was fighting for her place in a world ruled by men, where a woman in physics was seen as either a system glitch or a total anomaly. I mean, Skłodowska Kiri. Back in high school, as the only girl, she finished on all-boys gymnasium in Zagreb with top grades in math. At the Zurich Polytechnic, she was one of the first women in history to study physics and math. For Einstein, getting in was a success. For her, it was a fight against the whole system. And Mileva had a limp from a childhood illness. She didn't have a classic look. She didn't fit to the beauty standards of the time. But Einstein, he didn't care at all, because Mileva thought like him. She felt the science, and she also felt him. They fell in love in their second year of studies, even though Einstein was still in a relationship with another girl, Maria Winteler, a family friend. Everyone thought Maria would become his wife, even Maria herself, but long-distance relationships didn't really work, even 100 years ago, and Mileva, she was right there, close by. And she was exactly what Einstein needed, a mind sharp as a razor, and soul that truly understood physics. And their letters from that time include some pretty clear hints. For example, Einstein once wrote to her, quote, "We understand the dark sides of our souls so well, and we are so good at eating sausages, drinking coffee, and doing something else together." I think if he had Messenger today, he would probably end his messages like this. There was one problem. Actually, a few. Albert's parents didn't accept that relationship. Mileva's parents didn't either. She wasn't seen as a good match. She was limp, was older than Einstein, didn't have a diploma, and didn't look like the beauty standard of that time. But so what? In 1901, Mileva got pregnant. Einstein, he was looking for a job. She was preparing to retake her exams because she failed the first time and couldn't graduate with Einstein. She went back to Serbia, then gave birth to a baby girl, and that's where one of the most mysterious parts of Einstein's life begins. The child, named Giselle, disappeared from the records of history. All we know is that she didn't live long. Maybe she died of scarlet fever. Another version is she was given up for adoption, but one thing is certain, Einstein never saw her. Sounds dramatic, right? Because it was. Mileva came back without the child. Her scientific career then disappeared. In 1902, Albert's father died, but not before giving his blessing for the wedding. In 1903, Einstein and Mileva got married quietly. In 1904, their son Hans Albert was born, and that's when things started to fall apart. Not suddenly, quietly, bit by bit, like something was breaking inside, but no one knew how to fix it. Mileva still wanted to be a partner, not a housewife, not just a mother, a partner. She talked with Einstein about physics, debated light, solved equations, but Einstein, he seemed distant, like he decided that science was now his world and she should just take care of the home. In 1905, Einstein published 4 legendary papers. In one of them, he thanked a friend from university, but Mileva, not aware. Did she co-create those theories? Probably not in an official way. She didn't invent a new equation, but she helped, gave advice, did the math, keep him going, and then she took care of the baby and washed the diapers. In 1910, their second son, Edward, was born, but the family wasn't holding together. Einstein got an offer from the German Academy of Science. He moved to Berlin, and Mileva, she stayed behind with problems. Mental health problems. Her family had a history of schizophrenia, and it looked like it was starting to show again. The marriage was hanging by a thread. Einstein was diving deeper and deeper into his work, into theory, into equations. And then Mileva found out that Albert was having an affair. With whom? With Elsa Löwenthal, his cousin. Elsa's father was a cousin of Albert's father. She was a divorcee with 2 kids. And Elsa was different. She didn't analyze equations, she didn't argue, she didn't question. She was calm. And after years of stress and inner conflict, that's exactly what Einstein wanted. Silence, an escape from tension and from his own guilt. At this point, Einstein had everything: fame, respect, academic power, but one thing he didn't have was gratitude, appreciation, and he found it in Elsa's arms. Mileva already knew that Albert was having an affair with Elsa. Albert knew that Mileva wasn't exactly innocent either. Both of them had their secrets, their frustrations, their wounds, but still they didn't want a divorce. Maybe because of the kids, maybe out of convenience, or maybe out of fear that the whole structure they would build for years would collapse. So Einstein did something that, from today's perspective, sounds like a scene from a dark comedy. He offered Mileva a contract, a real written agreement with bullet points, like a company deal. He turned their marriage into a technical arrangement. Here are some of the terms from Einstein's marriage contract. First, Mileva is responsible for running the entire household. Next, she must make sure Einstein has regular meals and a clean home. Third, she must leave the room immediately when he tells her to. Then, she must not expect any physical closeness. And last but not least, she must not speak to him unless he starts the conversation. It sounded like a contract between a genius and a servant, not between 2 people who once sat together working on the theory of relativity. But Mileva agreed. She tried to live like that for a while, but after a few months she couldn't take it anymore. She packed up the kids and moved to Zurich. And according to friends, that's when Einstein cried in public for the first time. The official divorce, it didn't happen until 1919. That's 5 years later, but even here, Einstein wasn't just anybody. He played the divorce like a chess move. He offered Mileva a rather unusual deal. You will get all of my future Nobel Prize money. Because at that time, he hadn't won it yet. But he was convinced he would, and he was right. In 1922, Einstein received the Nobel Prize in Physics, officially for the photoelectric effect, along with the monetary award from the Swedish Academy. 121,572 Swedish kronor. Adjusted for inflation and converted to today's money, that's around $4 million, maybe even more. That money went to Mileva. She used it to buy, among other things, 3 apartment buildings in the center of Zurich. It was her reset, her personal compensation, and maybe the only moment in this whole story when she got something truly for herself, not because of her husband. But let's be clear, this wasn't a gift, it was a transaction. Alright, back to 1905. Young Einstein, 26 years old, a third-class clerk. No PhD, no university post, no prestige, and yet he drops 4 papers that tear down the whole structure of 19th century physics. Okay, maybe not tear down completely, let's say major renovation, like bam, full makeover. And he does it not from a university podium, but from his desk at the patent office. In between reviewing application for fancy corkscrews and sewing machine gears, for real! I think I would go insane, or actually, new corkscrew design. Kinda cool! Einstein's ideas were so strong, so out there that many brilliant physicists didn't even try to understand them. Others just couldn't accept they came from so no-name patent clerk with a mustache reading Maxwell in his free time. But to really get what just happened, we need to rewind. Take one step back and see what science looked like in early 1900s, because back then the world was oddly confident itself. By the second half of the 19th century, people genuinely believed that physics was basically done. Newton's mechanics? Check. Maxwell's electrodynamics? Check. Light waves, electricity, magnetism, all of it seemed to be figured out, measurable, predictable, like physics was complete, sealed, and delivered. Scientists started saying it's just polishing now, just tweaking the edges, kind of like beating the main storyline in a video game and now you are grinding through the side quest. That's exactly how I finished Witcher and Cyberpunk. And honestly, I think it's time we go back there. But okay, let's be real. Suddenly a bulldozer rolled into physics. A bulldozer with Einstein painted on the side. But before that happened, we need to talk about one guy, Lord Kelvin. Well, actually, William Thomson. Lord was a title he earned later for his achievements. He took it from the River Kelvin in Glasgow. That's where he taught at the university. He is the guy who created the absolute temperature scale, where 0 means zero energy. Brilliant guy. Worked on the second law of thermodynamics. Even tried to calculate the age of the Earth, and let's just say he got it so wrong it's kinda embarrassing to bring things up. Honestly, before his time, people had some serious messed up ways of measuring temperature. You could probably call that the Great Temperature War era. And you know what? I was going to say, hey, maybe if this video get 1 like and 1 comment, maybe I will make an episode about it, but screw it, I'm doing it anyway. Okay, who cares? I mean, yeah, drop a like if you can, always helps, but it was him, Lord Kelvin, who dropped one of the biggest physics bangers around 1900. Paraphrased, there is nothing to be discovered in physics now. All that remains is more and more precise measurement. Yeah, that aged like milk, because how wrong he was! The early 20th century was a moment of explosive knowledge. Science was racing forward like a runaway train with no brakes. People felt we were just one step away from understanding all of reality. But the first crack? That came back in the 17th century when Isaac Newton discovered gravity, force and motion. Suddenly everything became predictable, balanced, mechanical, and falling apple and an orbiting planet had same rules. We had attraction, we had a world that ran like a perfect clock. Newton's world was clean and analog, cause, effect. Everything could be described with equations, And if something didn't make sense, that just meant you need to measure it better. Then, in the mid-19th century, Michael Faraday brought something Newton never saw coming. Fields. Invisible forces stretching through space. Electric current, it made a magnetic field. A changing magnetic field, boom, it created electric current. It's, some balance. It was something new, something more alive, more flexible, a world of invisible interactions. And then came James Clerk Maxwell, math guy, physics guy, who wrapped it all in equations. 4 elegant formulas that showed an electric field can make a magnetic one, and a magnetic field can make an electric one. And from all of that came something even bigger. Light. Light is an electromagnetic wave. And what's more, it always moves at a constant speed. Always at the same speed, 300,000 kilometers per second, no matter who is watching it or how fast they are moving. And that's where we hit a dead end. One that only Einstein will manage to escape, because if light always travels at the same speed, then something doesn't add up with our intuition. Then if you are flying toward a beam of light at 100,000 kilometers per second, then logically you should see it moving slower, right? Around 200,000 kilometers per second. That's how regular motion works. If you are driving at 60 and another car is driving 50 in the same direction, you are only going 10 faster relative to it. Same thing should happen with light, right? Well, nope. None of this fits together. Newton talked about masses, forces, and gravity. Maxwell about electric fields, magnetic fields, and electromagnetic waves. These two worlds felt like stories from completely different books. But physicists didn't want a revolution. They wanted peace, so they started tapping everything together with something called the ether. What was that? Ether was supposed to be an invisible something that filled the entire universe. A kind of a magical fluid through which light waves could travel, just like sand moves through air or ocean waves ripple through water. Everyone believed in it. Ether was needed to make Maxwell work just as nicely as Newton. Without ether, something didn't add up. But then came a problem. In 1887, Michelson and Morley ran an experiment that was supposed to prove the existence of the ether. They built a device so sensitive it could detect even the tiniest changes in the speed of light. If the Earth really was moving through this ocean of ether, of course. The result? Nothing. Zero difference. Light traveled at the same speed in every direction, as if ether didn't exist at all. Physics lost its scratch. Light was moving with no medium? How was that even possible? And then came the thing we've mentioned like 15 times already in this episode, the ultraviolet catastrophe. I mean, classical physics said that if you keep hitting an object, it should start radiating more and more energy, eventually hitting infinity, which meant a hot piece of metal could, in theory, destroy the universe. I know it sounds the same, because it was, and that's when Max Planck steps in. He pulls a trick. He says energy isn't continuous. It comes in packets, quanta. That's how Planck's constant was born, a tiny number hiding in an equation, one that will change the entire world. But even Planck didn't fully believe in what he had created. He thought it was just a mathematical trick, and that's when Einstein shows up. No title, no university chair, just a cup of tea in one hand and a notebook in the other. And he says, it's not a trick, it's not a coincidence, it's the truth. Einstein proves that light isn't just a wave, it's also a particle. It carries energy and it can knock electrons out of metal, something a wave can't do. And this wasn't yet the Einstein of relativity. This was the Einstein from a wave-particle duality, and that's exactly what got him the Nobel Prize in 1921, not for the E equals mc squared, but for this. Most people think they understand the theory of relativity, and to visualize it, there's this classic line: a minute can feel like forever, depends which side of the bathroom door you are on. Undeniable wisdom, because time, as it turns out, isn't some universal stopwatch. It's something much stranger. For centuries, the world seemed simple. Newton described it like a theater. Space was the stage, matter the actors, and time ticked in the background. The same for everyone. Mechanics were analog. Everything made sense. But then in the 19th century came trains, clocks, stations, flashes of light, and one problem. While working at the patent office, Einstein saw lots of patents for clock synchronization systems. And he started wondering, if you send a signal from one city to another, how do you know that two things happened at the same time? That question hit him hard. What exactly is simultaneously? Sounds simple, right? Two events happened at the same time. Seems logical, but Einstein turned it into a thought experiment, and then everything fell apart. Imagine a train station. You, the observer, are standing exactly in the middle of the platform. On your left, there's one track. On your right, there's another. Suddenly, boom! Two lightning bolts strike at the same time. One on the left, one on the right. And you see it happen. The light from both flashes reaches your eyes at exactly the same moment. So what do you say? Well, obviously, they happened at the same time. Easy. But now Einstein says, alright, now imagine there's train passing by the platform. Fast, really fast. And inside that train, right in the middle, there's a woman standing. At the exact moment two lightning bolts strikes, the woman is right next to you, also in the middle class, but she's moving with the train. And now the magic begins. The flash at the front of the train, the direction it's moving, it's coming toward the woman. She's moving toward it, so the light reaches her faster. The flash at the back of the train has to catch up to her because she's moving away from it. So that light arrives with a delay. So for her, the first flash was the one at the front. The second was the one at the back. But you, standing still on the platform, see, both flashes arrive at the same time. So who's right? Einstein says both, he and she, because time is not absolute. It's not like a minute is a minute, a second is a second. It depends on whether you are moving or standing still. There's no such thing as objective simultaneously. What happens at the same time for you might happen earlier or later for someone else. And if time depends on the observer, that means time is relative. That's why the twin who spent his life in orbit will return younger than the one who stayed on Earth. Sure, he's back in ruined from sitting in the spaceship, but his cells aged slower. Welcome to the world of relativity. I know it sounds like a science fiction, but now imagine what scientists felt in 1905. They get a paper from a young clerk in Bern and read, "Time is not absolute. Simultaneity is an illusion." Nobody knew what to do with it. No Nobel, no professorship, no applause. It was a scientific shock they had to swallow. And even Einstein himself wasn't really ready for what he had just created. Because in 1905, Einstein launched the special theory of relativity. Why special? Because it only works in special cases, when everything moves at a constant speed. No acceleration, no turns, no forces, straight and steady. But those conditions almost never happened in the real world. But Einstein didn't want half-baked physics. He wanted something bigger, something that worked all the time. And for the next 10 years, he worked on it alone. no titles, no team, no applause, until one day, not in lab, not in a library, but while shaving in the morning, he got a thought he later called the happiest thought of my life. I know it sounds romantic, exactly, because sometimes the biggest revolutions don't come from a blackboard, but from the steam on a bathroom mirror. And that thought was, a man falling from a roof doesn't feel his own weight, right? That was the moment, the starting point. From this one simple observation came the general theory of relativity. Instead of searching for equations, he searched for images. And that's how the famous elevator experiment was born. What experiment? Imagine this. You are standing in an elevator. The elevator is on Earth. You feel your body's weight. You are holding an apple, you let it go, it falls. Normal stuff. But now the same elevator is flying through space in a vacuum. No gravity at all, but it's accelerating, like with a rocket engine. And suddenly the same thing happens. You feel your weight. The apple falls to the floor. How is that possible? There's no gravity. Yet everything looks exactly the same. And that's when Einstein captures it into one sentence. Gravity and acceleration are the same thing. You can't tell them apart. There are two sides of the same coin. Now, on this one idea, Einstein built his entire general theory of relativity. Now, mass could bend time. And bent time told mass how to move. Planets didn't orbit because something was pulling them. They moved in straight lines through curved space. Earth doesn't fall into the sun. It moves in a straight line. It's just that space isn't straight. That was the revolution, but it wasn't science fiction. Einstein wrote down the equations. Equations that would be confirmed by experiments years later. But back in 1915, almost no one understood it, and even fewer people wanted even to try. Okay, so now the big question. How does gravity really work according to Einstein? Imagine a huge bedsheet stretched out in every direction, a kind of fabric, like the stage of the universe. Now place something heavy right in the middle, like a bowling ball. What happens? The fabric bends. It creates a dip, a curve. Now toss a few smaller balls onto that shit. What do? They start rolling toward the center, not because something is pulling them, but simply because that's how space is shaped. This is the simplified version of gravity in general relativity. There's no magical pulling force. What we have is curved space, and in that space, objects move along the straightest path possible. But here's the catch. In a curved fabric, that straight line is actually a curve. The sun doesn't pull the earth. The sun bends space-time, and Earth just rolls through it, just like a marble rolling across the stretch-out bedsheet. But here's the thing. This model isn't just a pretty metaphor. Einstein described all of this using math. He came up with equations that predicted, among other things, the bending of light by gravity and the strange shifts in Mercury's orbits. Things Newton couldn't explain at all. And here's something worth clearing up. That famous equation, E equals mc squared, the one literally everyone knows, didn't come from general relativity. It was actually part of Einstein's earlier work, the special theory of relativity from 1905. He showed that mass is just frozen energy, and energy can become a mass. A simple formula with consequences that stretch all the way to nuclear reactors, medical radiation, GPS, and the atomic bomb. And actually, GPS works thanks to Einstein for another reason too. Because his theory showed that gravity doesn't just bend space, it also bends time. The closer you are to a massive object, the slower your second tick. That's not a metaphor. The clock inside the GPS satellites really do tick faster than clock on Earth, and we have to fix that difference every single day. Back in 1905, all of this sounded like black magic, even to physicists. And even though we learned it at school today, it's still hard to fully wrap your head around. But one thing is clear, Einstein started a revolution, not because he was the best at equations, but because he had imagination. He could see reality in a completely new way, and he had the guts to ask questions no one else even thought to ask. That's why he got the Nobel Prize. That's why his face is on t-shirts, mugs and tattoos. That's why everyone knows the name Albert Einstein. But how exactly did he become the biggest celebrity in science history? That's a whole different story. A story about media, propaganda and cosmic PR. Alright, it's the 21st century. Einstein is everywhere. But to really get it, we have to go back to the early 1900s. Back then, he wasn't the Einstein from textbooks. He was the Einstein from newspapers. The guy whose face was known all across Europe. And not because he solved gravity, but because he was different, media-friendly, sharp, and most importantly, controversial. Because every story needs a hero, but also a villain. For Einstein, the villain was the rising wave of antisemitism. He came from a Jewish family, but he wasn't religious. For years he described himself as humanists, maybe an agnostic. Still, to many people, he was just that Jewish physicist. In 1914, World War I began. Germany invaded Belgium. The entire Academy of Sciences signed a letter supporting the war. Everyone, except one man, Einstein. A single name against the violence. In a time full of nationalism and pride, he had the courage to say no. After the war, Germany was humiliated, poor and angry. People wanted someone to blame. Politicians were looking for scapegoats, and like many times in history, they pointed at the Jews. Even physics wasn't safe anymore. Some started saying that real German science didn't need any theory of relativity, that it was just a Jewish trick, that Einstein was messing with children's minds and threatening national identity. I know it sounds like a joke, but it wasn't. It was deadly serious. Paramilitary groups started showing up at his lectures. Einstein had to be escorted by police, and after the assassination of Walter Rathenau, a Jewish foreign minister, Einstein started carrying a gun. For months he avoided public appearances, but that only made him more popular. The more hate he got, the more people stood by his side. Because Einstein wasn't just a scientist, he became a symbol, a voice of reason in time of madness, a humanist who spoke the truth, not because it was friendly, but because it was true. The moment of truth is coming. Year 1919. Einstein had predicted something wild, something that for 19th century physicists sounded like a pure heresy. Light should bend in the presence of mass. Not just cannonballs have trajectories. Photons, too. If they pass close to the sun, they should drift, of course. Gravity should bend not just space, but also the path of light. But how do you test that? I mean, no one stares straight into the sun, right? So they needed an eclipse. And right then, an expedition sets off. A British guy, Arthur Eddington, physicist, pacifist, idealist. He organizes a mission to two places. The island of Principe in the Gulf of Guinea and Sobral in Brazil. Why? To photograph stars during a total solar eclipse. Stars that were right behind the sun's disk. Because if Einstein was right, the stars should look shifted. And they were, exactly as predicted by his equations. Boom! The world went absolutely nuts. The next day, headlines exploded. German scientists defeats Newton. Revolution in science. Sun bends light. New physics. New universe. And just like that, Einstein, that same guy from the patent office, becomes a global star. Not just in science, in pop culture, politics, and big ideas. When journalists asked what he would do if the experiments proved him wrong, Einstein just said that would be very sad. For God, because my theory is still correct. Was it arrogance? Maybe a little. But more than that, it was the confidence that the universe had a deep hidden order, and he had just cracked it. The world was recovering. From war, from trauma, from chaos. People weren't looking for generals anymore. They were looking for a thinker. Einstein, with messy hair, a chill attitude, and a peaceful message, became that person. He started showing up on the front pages. He became the face of hope and cool genius. But yeah, the more famous you get, the more pushback you face. In Germany, nationalism was rising again, and with it, antisemitism. Even though Einstein was a German citizen, a member of the academy, a professor, he was labeled as the symbol of Jewish science. Some professors started claiming things like real German physics must be hard and empirical, and this whole relativity thing just a Jewish trick. Sounds absurd, I know, but back then it was everyday talk. But Einstein didn't stay silent. He didn't pretend it wasn't about him. He said it clearly. Yeah, I'm Jewish and I'm proud of it. He didn't back off. He didn't run, and he never stopped thinking differently than everyone else. In 1921, Einstein arrived in the United States. At the dock, 10,000 people were waiting for him. A crowd, excitement, banners, they welcomed him like a rock star. But this time, it wasn't just the physicists. It was a symbol. For the first time in his life, Einstein became a public figure. He started raising money. He helped refugees from Europe. He supported Jewish scientists who were being thrown out of German universities. He helped them find jobs, grants, and a second chance. He also supported the building of a new science center, the Hebrew University in Jerusalem. And not just with his name. He gave the university his manuscripts, even the rights to his future inheritance. Einstein didn't just think, he acted. And years later, boom, the Nobel Prize. And not for what everyone knows him for. Not for the theory of relativity. He got the Nobel for explaining the photoelectric effect. The moment when light kick out electrons from the surface of metal. Today, that's how solar panels work, but back then it was a milestone in development of quantum mechanics. And here comes the biggest irony of all. Einstein, the man who helped create quantum physics, spent the rest of his life not really believing in it, because the quantum world was chaotic, random, and Einstein believed in order, in the harmony of the universe, in rules. God doesn't play dice, he said. But his rival, Niels Bohr, didn't agree. He said, "Don't tell God what to do." And boom, that's how one of the biggest rivalries in the history of science was born. Two brilliant minds, two different views. And the entire 20th century of physics cove between them. But Einstein wasn't just a physicist, he was a philosopher, a sensitive, sometimes melancholic man who tried to understand the meaning of life. And even though he wasn't religious in the traditional sense, he didn't reject spirituality. His God wasn't sitting on a cloud. His God was hidden in the structure of reality. He said, "A miracle is not when the laws of nature are broken, but when the laws of nature exist at all." When people asked him about faith, he gave the most beautiful answer. He said, "Imagine a child walking into a huge library. There are books everywhere. Each one talks about the universe. Everything is arranged in some mysterious order. The child doesn't understand the books yet, but it feels. This can't be random, and that's what I call being religious." Einstein didn't just think about stars, he also thought about people. For most of his life, he was a strong pacifist. He didn't want to join the army. He didn't believe in violence. He didn't support any war, but in 1933, something broke. Hitler came power in Germany, and antisemitism stopped being just a social problem. It became official state policy. Einstein, as a Jew, as a scientist, as a symbol, had to make a choice. And he made it fast. That same year, he left Germany with his wife Elsa forever. He moved to the United States. He taught, he published, but he also got involved. He helped refugees, he raised money, he supported Jewish scientists. He helped build the Hebrew University in Jerusalem, head and heart together. But Einstein's biggest dilemma was still ahead. In 1939, he signed a letter to President Franklin Roosevelt. The letter warned, "Germany might build an atomic bomb. We have to act faster." This was the letter mentioned in the Oppenheimer movie, by the way, and this was the letter that started the Manhattan Project. And here's the twist. Einstein had nothing to do with the bombs. US authorities saw him as too pacifist, too German, too left-wing. The FBI had a 1,400-page file on him. Hoover didn't trust him, and even though his name became a symbol of the atomic equation, Einstein was never allowed to join the project. And yet, in 1946, Time magazine put his face over a mushroom cloud with a big headline, E equals mc squared, as if he had dropped the bomb on Hiroshima. It was an injustice that hurt him for the rest of his life, because even though his formula explained that mass as energy, Einstein himself spent his whole life fighting for peace. It was Einstein who said, "I don't know what weapons will be used in World War III, but World War IV will be fought with sticks and stones." Until the end of his life, Einstein kept writing letters, giving speeches, begging for arms control, for disarrangement, for reason. And that's when it happened. Einstein stopped being just a scientist. He became a symbol, the face of resistance, the conscience of the world. So much so that in 1952, the government of Israel offered him the presidency. Seriously, Albert Einstein, president of Israel, it really happened. And even though he said no, believing he wasn't qualified, it became one of the most symbolic moments of his entire life. Because by then, he wasn't just a scientist, he was a symbol, a legend. But even as a legend, Einstein remained human with an obsession, one great obsession, to find a single theory of everything. To connect classical physics with quantum theory, to connect beauty with logic, to unite all the forces of the universe into one equation. He never succeeded. In 1955, he was taken to hospital with abdominal aortic aneurysm. He was 76. He knew he wouldn't live alive, but he refused surgery. He said, "I want to go with dignity. Artificially prolonging life is in bad taste." He died in the early morning of April 18th. In German, the language of his thought, he spoke a few final sentences. But the nurse didn't speak German, and no one wrote down his last words. That wasn't the end of Einstein. That was the beginning of the legend. Why him? Why did a patent clerk from Bern become the face of all science? The answer isn't just in the equations. First, his look. Messy hair, worn-out coat, a pipe, and that gaze off into the distance. He looked like the idea of a genius, and the world loved it. Second, he was human. He played the violin, loved long walks, didn't wear socks, lost his keys, had a stormy personal life. He wasn't some out-of-touch professor. He was real. Third, the media. Einstein didn't hide in a lab. He gave interviews, dined with politicians, appeared at high society events. In a world still learning what PR was, he just got it. But the most important thing, he never stopped asking questions, even when there were no answers. After his death, Einstein's body was cremated, but his brain was kept. Pathologists Thomas Harvey removed it without the family's permissions and sliced it into pieces, hoping to find something more, something that could explain a genius. Over the decades, many scientists tried to figure it out, and what did they find? Nothing. No divine particles. No special gene to explain Einstein's mind. His brain wasn't miraculous. It wasn't magic. It was human, just like yours. What made him different is he's curious. So maybe that's the whole secret. Let's stay curious. Don't be afraid to ask questions. Don't be afraid to give stupid answers. Someone will always correct you. Just be curious. Because the ones who change the world aren't the ones who know absolutely everything. They are the ones brave enough to ask why.